Students, today's class will be discussing about configuration of transistor circuit. Next we shall see what are the various types of configuration. One is common base configuration, next common emitter configuration, third one is common collector configuration. So here is the circuit for common base configuration. So you can find that as the name suggests, the base is common to both your input and output terminals. So emitter is used as an input terminal, whereas your collector is used as an output terminal. Is it fine? So now we shall see about input characteristics. So it is the characteristics curve between input voltages to input current, whereas output voltage is kept constant. So in order to determine input characteristics, the collector base voltage is kept constant and you are going to vary your emitter base voltage and your emitter current increases. So this is repeated for higher values of VCB. Next, we shall see about the graph which represents the common base input characteristics. A graph is drawn between your emitter base voltage and emitter current by keeping your constant, that is your collector base voltage is kept constant. Next we shall see about the output characteristics. So here we can find that it is a graph which is drawn between your VCB and your collector current by keeping your emitter current constant. So here it shows that it is IE is kept constant at 0 and collector current is increased from 0 by increasing your collector base voltage. The third one we shall see is about common emitter configuration. So here we can find that the emitter is common between your input and output. So base is used as an input terminal, whereas collector is the output terminal. So we shall see the input characteristics for common emitter. So in order to determine input characteristics, the collector base voltage is kept constant and your base current is increased from 0 by increasing your base emitter voltage. So here is a curve which shows between base current and base emitter voltage at constant collector base voltage. So this is the diagram which represents. So here you can find that the base width decreases, so the curve moves right as collector emitter increases, voltage increases. Next we shall find output characteristics. In order to determine output characteristics, the base current is kept constant at 0 and collector current is increased from 0 by increasing VCE. We shall find the output characteristics. The output characteristics has three basic regions. One is the active region, which is called as the biasing arrangements. Next is cutoff region. From the diagram we can see that the region where the collector current is OA. And the next is saturated region of the characteristics to the left of VCB is equal to 0 volts. The last one we shall see is about common collector configuration. So this is the circuit diagram which represents. Here again you can find that your collector is common between your input and output. So a curve is drawn between a base current and base emitter voltage at constant collector base voltage, which is shown in figure. Now this is what is the input C input characteristics. Where in C input characteristics you can find that your base collector voltage is kept in the x-axis and you have your base current in the y-axis, and you are keeping your emitter collector voltage as constant and you are having with respect to 2 volts and 4 volts. The last one we shall see is about the output characteristics, which is used to determine the output characteristics. The base current is kept constant at 0 and emitter current is increased from 0 by increasing your emitter current voltages. So you have the graph for output characteristics. So we can see that in your x-axis you have your collector emitter voltage, and you have in your y-axis we have emitter current by keeping your base current constant, and you can find the various values. Last slide is about your comparisons of common base, common emitter and common collector. So I've just given a tabulation column. So these are the property. Input resistance as far as common base is concerned is very low, common emitter is moderate and common collector is high. Output resistance, common base it is high, common emitter it is moderate, and for common collector it's low. Current gain is 1 for common base, high for common emitter, and high for common collector. Similarly, with respect to voltage gain is about 150 with respect to common base, and it is about 500 in common emitter, and it is less than 1 with respect to common collector. And there is a phase shift between 0 to 360 degrees in common base, and in common emitter it is 180 degrees, and as far as common collector is concerned it is 0 or 360 voltages. And some few applications you can find that common base can be used for high frequency circuits, common emitter can be used for audio frequency circuits, and common collector for impedance matching. Thank you.